So now what we're going to be doing is we've taken a look, preliminarily at least, what are quadratic functions. Now I think it's really important that we do some examples of quadratic functions, and then maybe later on what are non-quadratic functions so that we're able to identify what we're dealing with. Now I've written out the general form. The quadratic function is y is equal to ax squared plus bx plus c, where a can't be equal to 0, a, b, and c are element of the reals. So essentially our coefficients have to be real numbers, and the only real deal breaker of a quadratic function is when a is equal to 0. So I'm going to give you some examples of quadratic functions. So y is equal to x squared is a quadratic function. What we're able to see here is there's not much information, and in fact some of you may be complaining there is no x term and there is no constant term. That's true, but I also could write this x squared as 0x plus 0, and if simplified that would be y is equal to x squared. So that would follow the definition of a quadratic function. Also, this would be a quadratic function. It has the coefficients a, b, and c that are real numbers. Also, notice, like our previous example, we're missing a middle term that contains x. Don't fear, this is also a quadratic function. Y is equal to negative pi x squared minus 3.1 x minus 11 over 2. This is also a quadratic function. Now I wouldn't want to deal with this one. The coefficients a would be negative pi. Well, negative pi is a real number. Negative 3.1. And negative 11 over 2. All three of these coefficients are real numbers, and most importantly, the a coefficient is non-zero. And in fact, will allow me just simply to write our previous example. I could write this example as 2x to the power of 2 minus 7x to the power of 1 plus 1x to the power of 0. Now this is an odd way to look at a quadratic function, but really we have exponent 2, exponent 1, and exponent 0. What is really incredibly important is that we have an exponent 2. Now, let's look at examples of non-quadratic functions. Y is equal to 0x squared minus x minus 1. If you notice, this breaks the rule of a being 0. So here a is 0. This is a non-quadratic function. Quite simply because when a is 0, as you simplify it, you end up with a linear function. Furthermore, another example of a non-quadratic function is, if you notice, we have a variable underneath the radical. And some of you may remember that the square root of x can also be written as the x to the power of 1/2. So we can only have exponents 2, 1, and 0, not 1/2. Y is equal to, 4x squared plus x plus x to the power of negative 1. And again, this would be a non-quadratic simply because we have an exponent that is not 2, 1, or 0. Yet, what are the main ideas for identifying a quadratic function? Very simply, it has to be in the form y is equal to ax squared plus bx plus c, where a, b, and c have to be real numbers, and a can't be equal to 0. But the main idea is really to be able to spot out it must have a term with x squared in it. Exponents must be 2, 1, or 0. For sure, your equation must have a 2. The 1 and 0 are strictly optional.